All right, looking at our last section for Chapter P, Section 6, we are dealing with complex fractions. What makes something a complex fraction is that it has fractions within fractions. All right, so we have one big fraction here, but within it, we have fractions. All right, we want to simplify that down. Now, there's several methods that you can use to do this. The one I'm going to show you, I think, is going to be the fastest way for you. So step one is to consider every term as if it were a fraction. All right, put a 1 under it if it was just a constant number, but make it look like a fraction. All right, so I'm going to picture having a 1 under here and under there. Okay. The second step is to find an LCD of all the denominators. All of these little mini fractions that we've created now, we want to look at every denominator and figure out if we were trying to get it to be common, what would it be? Okay? We're not actually going to get them to be common, but we have to figure out what that LCD is. So, looking at my denominators, I have 1's and I have x's. So, my LCD here would be just a 1x. Okay? So we identify that LCD. Our third step is now to multiply top and bottom. So of this big complex fraction, we're going to take the whole top part and the whole bottom part, and we're going to multiply them by that LCD. Okay? The way I want you to write it, we're taking both the top half and the bottom half. We're timesing by an x. But I want you to, again, make it look like a little fraction. All right, so we're timesing by x over 1 to both the top and the bottom half. Okay? As long as we multiply the same thing to the top half and the bottom half, we haven't changed the problem, we've just made it look different. Okay? Now, to multiply, you are going to now distribute that x over 1 that we just wrote in red to all the pieces inside. Okay? If it helps you to write them off in the margin, go ahead. If you can do it in your head, that's fine too. I'm going to take x over 1, and I'm going to times it to this first piece, which is just 1 over 1. What do I get? An x. Okay. Then I'm going to take x over 1 and times it to the second fraction there. What do I get when I take x over 1 times 1 over x? What happens to my x's? They cancel out. What am I left with? A 1. Positive 1. And notice that by doing that step, our top half of this complex fraction no longer has many fractions in it. Okay? We got the denominators to go away. Now we're going to do the same thing on the bottom half. So we have x over 1 times 1 over 1, which we said was x. Then we have x over 1 times negative 1 over x. Again, our x's drop out. This time we end up with a negative 1. And we're done. We've simplified the complex fraction. That's it. Okay? I do want you to keep thinking about those restrictions. So go back to any denominator anywhere in the problem. All right? So in the original problem, what can x not be? Zeros. Okay. In my final answer, x can't be a 1, so I would want to include both. Okay. All right. Let's try another one. Look at all the denominators. What do you see? First of all, are there any where we have to create the fraction, where we have to put a 1 under it? No? Okay. So looking at our denominators, I see an x, I see a 2, I see another x, and I see a 4. If we had x's, 2's, and 4's, what would your LCD be? I'm hearing 2x. Keep in mind that our goal is to get all those little mini denominators to go away, right? So a 2x would allow me to cancel out x's here and the 2 there, that x Would a 2x allow me to cancel out a 4? No. So instead of 2x, I actually need 4x. A 4x would allow me to cancel a 2, right? But a 2x doesn't allow me to cancel a 4. So I need an LCD of 4x. So I am going to take that whole top half of my complex fraction and times by 4x. Again, I'm going to make it look like a fraction so that we can keep straight our numerators and denominators. Same thing for the bottom half. All right, we then distribute. So what do we get if we take 4x times 1 over x? What is going to drop out? What? The x's are going to drop out. So if the x's are gone, we only have 4 times 1, which is 4. Okay. Then I take the 4x and I multiply it. I just did that one. Now I need to do that one. Okay. So 4x over 1 times negative 3 over 2. Can I get that 2 to go away? Is there a way to reduce it? Okay, make this a 1, make this a 2. So it simplifies down to what? Negative 6x. Okay. Now, for the bottom half, we already did 4x times 1 over x, right? It was the same as what we had on the top part. So we did it right here, and we got just a 4. Okay. Last piece then is to take the 4x times the 3/4. What's going to drop out? Fours will drop out. We've got our denominators to disappear now, and we only have a 3x left. We could factor a 2 out of the top, out of the numerator of this answer, but is there a way to factor a 2 out of the bottom part? So we're not going to be able to reduce it out. It's fine to leave it like this. Restrictions. What would we say x can't be? Again, go back to the original problem. X can't be 0. And in my final answer, x can't be what? That was a little harder to figure out, right? We have to think a little bit more. If we have 4 plus 3x and we're trying to figure out what would make it 0, how would we solve that? Subtract the 4 over and then divide out the 3. So x would end up being negative 4/3. That would create a 0. So we're going to have to restrict negative 4/3 out of our domain. All right, take a minute and talk to the people at your table. Is there anything so far that has confused you? Or are we okay to move on? We okay? Perfect? All right. Denominators get slightly more complicated. Instead of just an x or a number, we might have a binomial like an x plus 3. All right? Step 1, remember, was to make everything look like little mini fractions. All right, so I'm going to put little 1s under there so I can really focus on what is the denominator part. So now I look at it and I see denominators that are 1s, and I see denominators that are the quantity x plus 3. What would my LCD be? The x plus 3. Okay, so we are going to multiply both top and bottom half of this complex fraction by x plus 3. Okay? So let's think about what happens when we distribute. If I have an x plus 3, and I'm timesing it by a 3 over 1, what do I end up with? 3x plus 9? Okay. what do I get if I take an x plus 3 and times it by, now it's a negative here, so I'm going to put negative 1 over x plus 3 because of that. What happens to those x plus 3's? They cancel out. So we end up with just negative 1. Okay. Looking at the denominator, it's almost identical to what we just have done, right? The only thing they've changed is the sign in between them. So when I take this x plus 3 times the 3, it's the same thing I did here. And we got what for that? Okay, 3x plus 9. And if I take the x plus 3 times the positive version of this, I'm just going to get a 1. All right. This one has some like terms that we would want to combine to simplify it. So we end up with 3x plus 8 divided by 3x plus 10. Is there any constant that we could factor out and reduce out? Okay, then that's our answer. What restrictions do I have to place on my domain? Go back to the original problem. It can't be negative 3. And looking at my final answer, what could it not be? Okay, picture subtracting the 10 over to the other side, dividing out the 3. All right. Again, our denominators get a little more complex. In order to figure out what our LCD is, we have to have it in factored form. So we're going to rethink of this one, x squared minus 2x minus 3. How could we rewrite that in factored form? X minus 3 and x plus 1? All right, so we're going to think of it that way instead. So if we were going to get a common denominator, what would we need to use? What do we need for a common denominator? Think about how you did this yesterday. If these were all your pieces, what pieces do we need? We need an x plus 1 and an x minus 3. Yes? We need both of those. All right, so we're going to multiply this one by an x plus 1 and an x minus 3. We're going to multiply this whole thing by an x plus 1 and an x minus 3. Now, it looks like that's going to make things really complicated, but remember, those denominators are going to drop out. So if we distribute to this top half of our complex fraction, we are taking x plus 1 times x minus 3, and we're multiplying it to 1 over x plus 1. So what disappears? The x plus 1. What do we have left? X minus 3 times 1, which is just x minus 3. Okay. Looking at the bottom half of our complex fraction. What's going to happen when we distribute these two x plus 1s and x minus 3s to the first fraction here? Everything's going to cancel out, right? What's left? Just the 1. Okay. What happens when we take x plus 1 times x minus 3 and now distribute it over here to 1 over x minus 3? The x minus 3's now drop out, and we get 1 times x plus 1, which is just x plus 1. Simplifying, what do we end up with? X minus 3 over x plus 2? Okay. X cannot equal what? Go back to the original problem. X can't be negative 1 or 3. In my final answer, it can't be a negative 2. Okay. All right, our last example seems fairly basic. I want you to make everything look like a mini fraction. So you should be putting a 1 under there and a 1 under there. Yes? Okay. What would my LCD be? Just a 5? Pretty basic LCD. We're going to times this by 5? Or times this by 5? All right. What happens in the top half? 5 over 1 times x over 5. What's going to drop out? The 5s. We end up with just an x. What do we get when we take 5 over 1 times the negative 1? Negative 5. Okay. On the bottom, what do we have to do? Is anything going to drop out? No. So we're going to have the 5 times the x minus 5? Yes? Now, I'm going to leave it like this for just a second. Can you see why? Yeah, there's a common factor of x minus 5 that I can reduce out. What's my final answer? 1/5. Any restrictions on our variable? From the original problem, there's no restrictions. There's no variables in the denominators. Okay. But here, what do we get? X can't be a 5. Okay. Question for you. If you had, say, a common denominator of xy that you were multiplying in, okay, and let's say on the bottom you had 2x plus 5y. What would we get here for a denominator? If you distribute 2x squared y plus 5xy squared? Okay. All right, assignment. You're going to do 59 to 70, and then 95 and 102.